dear student. I am Rakesh Chaubey from Sunbeam Sun City. My dear, today I will give you a knowledge about Cartesian sign convention which you are using for mirror as well as for lenses. I repeat, Cartesian sign convention which you are using for mirror and the lenses. It's more or less it is same, little bit here and there. So we will discuss that all those things. So let's start with the Cartesian sign convention mirror as well as lenses. Mirror as well as lenses. Because I'll tell you there's a little small difference when we'll deal with mirror and when we'll talk about with lenses. Let's start with the point number 1, my dear. The very first point, look at this diagram to understand the Cartesian sign conventions. My dear, you all know that whenever we draw a ray diagram, we draw first a straight line called principal axis. Principal axis. And you all know that here at this position, almost at the center, we are keeping mirror or lens. Okay. Now this point, the center point, is called either pole in case of mirror, or it is called optical center in case of lens. Okay, so and we keep the object on, always on object. This is called object. I am writing over here, right? Always kept left of mirror or lens. Always. That's for rules. That is all called Cartesian sign conventions. That's a convention. So that's a rule. So we have to keep the object always to the left of mirror or lens. Now let's proceed further. Now my dear, you are knowing that this is the object. From the object, the ray of light will go from here to here. This is the direction of incident ray of light. That is from left to right. You can see. Your incident ray of light is going from left to right because object is kept on the left side. Okay, you have done in class 10, but now please try to understand so that now there should not be any problem, because still the student is having a problem when it is minus, when it is plus. So do it fast. So the incident ray will go from left to right, that is from object to the pole or mirror. Now, pole of the mirror or lens. Now, if I measure, see, now what is the first Cartesian sign convention? All the distances, there are all distances, more than one. So all the distances should measure from pole, or you can say your optical center, because I am discussing both mirror and lens. In case of mirror oblique lens, for mirror it is pole, for lens it is optical center. Always, that's first Cartesian rule. So what is first rule? That all distance you will measure from either pole or optical center of mirror or lens. If it is mirror, we will measure from pole. If it is lens, we will measure from optical center. Now, that is first point. Second point. Now, my dear, as I said, you will measure the distance from pole or optical center, right? So suppose if I measure the distance in this direction, here I am doing with the blue pen. So if I measure a distance in this direction, so I will say this distance measured opposite to the direction of incident ray of light. Because if I measure the things from here, I have to measure from pole or optical center. So if I measure the distance in this way, that is from right to left, that is from pole to this direction, of course I am going opposite to the incident ray. So that's what I have written. Distance measured opposite to the direction of incident ray of light is considered as negative. Here I have written negative. So all this distance which I will measure, if I got the focal length here, if I measure, suppose यहाँ पे I mark F, and suppose I am getting F here, that F will be minus, because that F is on this side. If here I will mark C, right, this C will be from pole, it will be minus R. This is object, it will be minus U. Because I have measured this, because I said the distance measured opposite to the, this is the point number 2, the Cartesian sign convention 2. Distance measured opposite to the direction of incident ray of light is considered as negative. Here I am measuring this distance. So this all will be minus. Now, my dear, but the distance can be measured. This is point number 2. Point number 3, here I am writing. But my dear, we can measure the distance here also. That is, distance is measured, this distance you can see is measured in the same direction as the direction of incident ray. Incident ray is going from left to right, even this is going from left to right. So here I am writing L to R, and this is R to L. Because if this is L, it is L. So it is R, it is R. You can see. So this distance on this side, because if I write here as F and here as C, then this F will be plus F and this C will be plus R. I hope it is clear. So here what will be the point? Point number 3 for this. Point number 2 is for this. The distance measured in the direction, this distance is measured, please look at it properly. This distance, if from pole or optical center I measure the distance that way, this distance. So you can see, you can make English that this distance is measured in the direction of incident ray, because incident ray always, I said, go from left to right. So this is also going from left to right in the same direction, but this was going in the opposite direction. So I considered any measurement on this side is minus. But if I do any measurement, suppose if I got focal length here, suppose I got center of curvature on this side, depend upon the shape of the mirror and lens that I will tell you today in my other lectures. So here if I F, I and here there is a C, that will be plus F and plus R, because it is measured from this to this side. That is from, I mentioned, from left to right, or you can say, sir, it is measured in the direction of incident ray. So here I will write the distance measured in the direction of incident ray of light the distance, this is the distance measured in the direction of incident ray of light. I have measured this distance in the direction of incident ray of light, and this distance was measured in the direction opposite to incident ray of light, is considered as is considered as positive. Is considered as positive because this is negative. I hope it is clear. Right? You have done this all in class 10, but this is a kind of a revision. Still, if you will not get clear, please be inquire with my email. I don't think a student are observing a video also, because I am not getting so much email questions. If you are observing a video, you please ask any questions or any doubt with respect to the topic. And now, point number 4. What is point number 4? Now, my dear, suppose I got the about point number 4. Suppose this is the object, and now the object is up, down, this like this, right? It is up. You can see. So, and you all know from class 10, this is called size of the object. No doubt this is extended object. In my video, I told what is extended and what is point object. So, this is extended object. But sir, this is the size also. We call size, you know, from class 10. Similarly, we get image also. Sometime like this or sometime down like this. So, this can be an image. So if I get the object, because object is always like up, an image can be up or down. Try to understand. Your object, whenever you draw the diagram, your object will always like this. That is, it point upward. Always it point upward in the ray diagram. कुछ चीजें हैं जो fixed हैं. So your object is always point upward. But your image which you will get in the ray diagram, I am not drawing because here, because I will not draw any condition or any cases here. I have just showing the plane that how you will learn the Cartesian sign convention. So you know that what I said, object is always in the upward direction, pointing upward. But image which you will get can be erect or can be inverted. Can be erect or can be inverted. It means can be upward, pointing upward, that is erect, or can be pointing downward, that is called inverted. So my dear, in that cases the topic is made that the distance, here I am drawing, in short, this is your principal axis, and here I have drawn like this. Am I clear? So here this is the distance. That's what I'm talking about. So distance measured upward. So this distance is measured upward, you can see. So the distance measured upward, and how it is? It is perpendicular. You can see. So this is the distance. This is the distance which measured upward and perpendicular to the principal axis. So this distance is measured. This distance, you can see in the diagram, is measured upward perpendicular to the principal axis, considered as positive. And the last point, my dear, you can take opposite of this. I said, if the distance is like this, if this is the distance and this is the principal axis, so the distance is like this. So here the diagram says See figure, here I am writing. See figure. So what is happening here? Same thing, the distance measured downward. Here it is downward and perpendicular to the principal axis considered as, come on, negative. So these are the 5 crucial Cartesian sign convention which you can use for mirror as well as for lens, my dear. So I hope you all clear. So what are the 2 important points? Sir, object is always kept left of mirror or lens. And second, we have to see the direction of incident ray of light. And it is but obvious, if it is the object kept on left, ये तो sure है. So the incident ray will be start from object. So 100% it will move from left to right like this. So if I move from left to right or in the direction of incident ray, then I will take that distance in positive. Okay. So now this is the pole. So if I have to measure the distance here from pole or from optical center, that is my rule, because I have to measure from here. मैं और कहीं से measure नहीं कर सकता. So that is rule. All the distance should measure from pole or optical center, depend mirror or lens. So if I measure the distance here from pole or from optical center, that direction you can see. So it means I am in the direction of incident ray. Incident ray भी ऐसे ही है. Major event ही also ऐसे ही हो रहा है. So that all positive. So that's what we can. The distance measured in the direction of incident ray is considered as positive. But the distance which measured in the direction opposite to the incident ray. So if from pole or optical center, if I start measuring the distance this side, of course मेरा incident ray यही रहने वाला है, from left to right. So I am measuring opposite to it, and therefore it is considered negative. And the third, fourth, fifth was, if the distance is upward, like your number line, this is like your number line. So this is going up, it is positive. If it is going down perpendicular to principal axis, it is negative. So ultimately it is number line. What is happening in number line? Number line. This is number line. So remember this at least. Remember number line. So here all is considered as positive. Say this is pole or optical center. I am writing here pole or optical center. The distance which you measure here is all negative. The distance which you measure up is positive, and the distance which you measure down is negative. So remember number line, that will be matching with your Cartesian sign convention. Exactly like that we measure all the distance from 0 on the number line, because here there is a 0, where in the case of mirror it is pole or optical center. That's all. Please write down so that I will proceed for the next. That is, my next topic is, my dear, reflection now from the surface of concave and convex mirror. I repeat, the topic is reflection from the surface of concave and convex mirror. Please fast.